Good morning! Okay, we got a pretty simple one today. This carrier unit needs a new economizer controller. I'll teach you guys what an economizer does and how to replace one to a new Jade. It's a little snowy today, a little foggy out, you know. Pull that off there. Clean off my workstation, you know. So in the filter section, something called an economizer. This is an economizer. So what it does is it receives a cooling input, then checks the outside air temperature. It uses this sensor down here. You say, hey, is it cold outside? If it's lower than, in my area, 55 degrees Fahrenheit dry bulb temperature, some places use enthalpy and humidity, it disables mechanical cooling and instead open up a set of dampers. See how those dampers are shut mostly? Those dampers will open and my return damper will close. That's this guy down here. See in here, that's down to the space. That will shut, this will open, and it'll suck in outside air. Fans on the other side of those filters. So let's quickly swap you out. There we go, a new Jade Economizer, put it on good. So this is the stuff that I've used to retrofit an older W7212 to a Jade Economizer. And really all I'm looking at is this section here. W7212 wire termination to the W7220, and I'm just moving wire to wire. It's really straightforward. It's not complicated at all. We also replaced that guy down there. And over here on the fan side, son of a bitch, let's get you out of here. We have to replace this thing here. Hard to believe, but this is a mixed air sensor. This is a 10k ohm NTC sensor, negative temperature coefficient. These two wires here go back to our Jade Economizer. So let's put in a new sensor. There she is. Dry bulb sensor. Again, we don't use much of enthalpy or humidity up around here. It's just too damn dry. Whew. All right, let's get a little more technical. What this unit was doing was bringing on one of its compressors to cool the space instead of opening up one of those outside air dampers. These units do not have low ambient kits, and that would involve a crankcase heater, staging for the fans, to get the head pressure, keep the head pressure up, or anything like that. So it's minus 20 out here, minus 20 Celsius. Can't run the compressor. And why would you when you can just suck in outside air? So those of us that know what we're doing, we know that from the thermostat, R is power, Y1 is first stage cooling, Y2 is second stage cooling, W is heat, G is fan, C is common. So when a thermostat closes its cooling contacts, it closes Y1 and G at the same time. So from R to Y1 and R to G. G turns on that fan there. Y1, inside here, has a wire. Goes way over here to our economizer controller. On Y1I. Y1 in. Any of my controls guys out there? I's and O's, input, outputs. Y1 input. This guy gets power at R and C, just like the thermostat does over there. When the fan turns on, it boots up, says, hey, what's going on? It'll open this to a minimum position because I want it to. I want a little bit of outside air. Positive pressure in the building is good. When it sees a Y1 input, it'll say, whoa, man, you want cooling? Right on, dude, let's go. It'll check the outside air temperature, make sure it's lower than whatever I set it at, which will be 55 Fahrenheit in my area or 12 degrees Celsius. It'll say, hey man, I don't need mechanical cooling. It'll open up this damper even more, close my return air damper, and begin sucking in outside air. Now that's sensor that I put in on the fan section is also being monitored, the mixed air temperature sensor. It's right here, MAT, mixed air temperature. OAT was this one underneath here. Mixed air temperature. It's trying to maintain a specific temperature. You don't want to just open this thing all the way and have you freeze everybody inside. No, no, no. You want it to be about 55 Fahrenheit. That's a good air conditioning temperature to be dumped into a space. So it'll actually modulate the damper. It'll have it mostly open. Oh, I'm getting too cold. Block it off and it'll mix my return and my outside. And that's what this guy does. It also helps with indoor air quality if it's so equipped. Auxiliary contacts, exhaust fans for more indoor air quality. I really like the RTU Economizer. It's pretty cool. Okay, let's turn it on, set it up, and put it into practice and show you what it does. So we simulate a call for cooling by jumping out R to Y1 and R to G. Turn it on. The fan motor turned on in there, I just heard it. This started to boot up. Nice. I'm going to change some set points and then we're going to watch the damper actuator. We can look at that. I had it open for too long. This has a freeze alarm, so it basically looked at the temperature that's in the mixed air section. So it said, hey, it's below 32 Fahrenheit or 0 Celsius. Close the bitch. So it closed this damper. I am done all my setup though, so we're going to put this panel back on and we're going to watch the damper underneath open. Awesome. Can I just take a seat and watch the show? Oh. There we go, ladies and gentlemen. She is open and modulating. We're sucking in outside air to cool down the space. Woo! Let's put that thing back on. Oh, nice. We can see in here that our returner damper is shut. There's nothing coming from inside. It's all coming from outside. Hell yeah, right on. Woo! And as a side note, if the outdoor air sensor sees that it's above 55 Fahrenheit, it'll actually close its Y1 output. So Y1 in comes in, this says, yeah, no, it's warm outside, let's turn on some air conditioning. And then Y1 will send power to engage my mechanical cooling. Science!